and good morning, America. We are here today on Mario Capecchi's birthday, October 6th, to discuss his fascinating achievements. Mario Capecchi was born in Verona, Italy on October 6, 1937. When Mario Capecchi was only 4 years old, he was left on the streets of Italy to fend for himself until he was 8. He emigrated to the United States shortly after World War II, and from 1967 to 1969, he was a junior fellow of the Society of Fellows at Harvard University. Later, he became a geneticist and professor at the University of Utah. Some fascinating contributions made by Capecchi are that he found out that DNA was randomly incorporated into the genome in the same orientation. He also pursued systematic analysis of the maize-hots gene family. This gene family plays a key role in the control of embryonic development in all multicellular animals. But his most famous accomplishment would have to be the winning of the Nobel Prize in 2007 for his discoveries of principles for introducing specific gene modifications in the mice by the use of embryonic stem cells. And I understand that Dr. Capecchi is here to discuss these discoveries. Hello, Dr. Capecchi.
Hello.
Can I call you Mario?
Yes.
So, Mario, I understand that you made some pretty important discoveries concerning gene targeting. Is this correct?
Yes.
So, what exactly is gene targeting?
It's a method, essentially, of being able to change any gene in any conceivable manner in an organism. And our particular organism is the mouse. And so what we want to do, the mouse has many genes, 30,000 genes, and this allows one to selectively inactivate a particular gene. And for example, if little finger disappears, then we know we're in the program for making little finger. And then that way be able to deduce essentially what each gene is doing by what outcome to the mouse is when we modify a particular gene.
Oh, so how is this done exactly?
These experiments actually started back in the 1970s. Richard Axel and Wigler had shown essentially if you make a precipitate of DNA and put them on top of cells, the cells eat the DNA, and then a certain amount of it would then go into the genome and be functional.
Wow! So, then what did you do?
So, we repeated those experiments, and what we noted is if we put in multiple copies of the same DNA, what we found is that again, that all of that DNA went randomly into the genome, but something very unexpected was seen. DNA has a direction. You read it from, say, left to right. And so what we found is that all the DNA molecules were lined up next to each other in what we call a concatemer, a head-to-tail concatemer. They're all in the same direction. Now, randomly, that's impossible because we would put in 1,000 copies, and 1,000 copies would all be head to tail, head to tail, head to tail. So there were only two possibilities for how this could happen. One is that one would act like a template, and then like a sausage machine, then turn out more and more copies, and they would all come out as one large concatemer, again, head to tail. The other is by a process called homologous recombination, where in essence two molecules which have the same sequence can be split and be put together again, and then again we would have a head-to-tail concatemer.
Wow, that is just fascinating. Thank you, Mario, for coming in. It has been great fun. But it looks like we're out of time. See you next time on Jola Talks.